All right, so today we're going to go over exponential functions with percents and rates. All right, this is where we're going to get into more finances. Okay, so we might see words like principal amount, which is the initial amount. That's my starting amount. That's my A or my y-intercept. Then it will have an interest rate. That's my B. And it will always be either added to 1, so we'll either add it to 1 or we'll subtract it from 1. And we'll talk about that in a minute. If it is decreasing or going down, if it's declining, decreasing, or depreciating, we're going to subtract that rate from 1. And if it's compounding, increasing, or going up, we're going to add that rate to 1. Whoops. And we'll talk about what that looks like. All right, so you invest $1,000 in the bank. There's our initial amount. That's our A. So we're going to create the equation y equals $1,000 in the bank. And then you receive 1.5% interest. So your money is growing at a rate of 1.5%. Okay, so we have got to add that to our amount. So our amount is our 100% was the $1,000. So we're going to add that percent to 100% and change it to a decimal. So 100% plus 1.5% gives us 101.5%, and we change it to a decimal. So we move that over, and it will be 1.015. Okay, times the time, and in this case, the time is annually, which is by the year, so the time is years. Okay, so we can see by this table that at 0 years, they have $1,000. At 1 year, they earned $15. At 2 years, they earned another $15.23. At 3 years, they earned another $15.45. So it's continually going up. And then we can see that by year 5, we're starting with the amount we left off right here. And when we apply the interest rate, it earned $15.92 that year and earned a total of $1,770.29. So we can see it's not going up a lot because 1.5% interest is not a lot. If it was a 10% interest rate or 12% interest rate, we would see a much bigger jump. But we can see that the money is earning money on itself. We're not doing anything with it. It's just earning money on itself. Okay, so when we're going up, we need to remember that we're going to take this amount, change it to a decimal, and add it to 1. Okay, so here we have y equals. We're going to take this amount and change it to a decimal. So we have our 1,000. We're going to take that amount and change it to a decimal. We'd move it 2 decimal places and add it to 1. So 1 plus 0.15. And then when we add them together, we get 1.015. All right. All right, let's look at it decreasing. The age of the national forest is declining. That means we're going to subtract it from 1. Okay, at 1% each year. So we're going to take 1 and change it to a decimal. So here's 1%. We're going to move the decimal place over 2 times. And as a decimal, that is 0.1. Okay, so now since we're declining, we're going to subtract it from 1. So if I take 1 minus 0.1, I get 0.99. Okay, so that's the rate that I'm going to use in my equation. So y equals, I'm starting with 20,000, and I am going to multiply it by my 1 minus 0.1, 0.01, which is our 0.99 to the power of x. All right, we're gonna skip this part down here. I already did all that. All right, let's see what happens. So we can see that the principal amount is going down. It's going down by 1% every time. And we can see that we're losing acres. All right, let's turn it over and look at the back. Okay. All right, so you've invested $2,000 in the bank and you receive 1.2% interest compounded annually. So compounded annually means we're increasing. So we're gonna use this equation right here. All right, so we are starting with 2,000. Our rate as a decimal, we would move that 2 decimal places and it would be 0.012. And then we're gonna add it to 1. So we would have 1.012. All right, so our equation would be y equals 2,000 times 1.012 to the power of x. All right, so at 0 years, we know that we're starting with $2,000. And we want to know how long it would take to get to 2,500. So this is where we need to go type this equation in to Desmos. We need to pull up a table for that equation by going into the settings button. And then we need to plug in some numbers until we get to this number right here. We need to get to 2,500. So what is this number here? So you're gonna find that for me. All right, and we get to 19. All right, a cup of coffee contains 300 milligrams of caffeine. All right, it's starting with 300 milligrams of 130 milligrams of caffeine. The caffeine is eliminated through the body at 11% per hour. Okay, so our rate is a decay because it's being eliminated. So we are going to use our subtraction right here. So our rate is going to be 1 minus, we got to change this to a decimal, so I'm going to move it 2 places. So it's 0.11. Okay, and as I do 1 minus 0.11, I get 0.89. So if I did 1 minus 0.11, I get 0.89. And so my equation is y equals 130 times 0.89 to the power of x. Now I want you to find in 3 hours. So we're gonna plug in 3 right here, and you're gonna tell me how many in 3 hours left your system. And in 3 hours, it was 91.6 milligrams. All right, we have a music festival in town. We are starting with this many people, so that's our y-intercept, that's our initial value. Okay, and it's expected to increase, so we're gonna add it to 1. We gotta change it to a decimal and add it to 1. So our rate is 1.085 to the power of x. All right, so we are writing equations. All right, number 6, we're starting with a car. It loses 12% of its value every year. So we're starting with an initial value of 21,500. It's losing, so we're gonna subtract it from 1, change it to a decimal, and subtract it from 1. So 1 minus 0.12. Okay, when I put that in my calculator, I get 0.88 to to the power of x. Now I can use this to see how much will the car be worth in 6 years. So plug that in your calculator. And in 6 years, we can see that the car is worth $9,985. All right, last one. A particular insect population triples. The initial population is 1,200. So y equals 1,200. We know it triples. How many will it have in 6 years? So this is just our basic regular equation. I don't have to, we're not talking about percents, we're not talking about money, so I don't have to add or subtract it from 1. So we're just using our basic exponential. So plug it into your calculator and tell me what you get in 6 years. So plug in a 6 right there and see what we get. You should get 874,800.